All right, so we're continuing to talk about polynomials, thinking about what their roots are. In this example, we are being told that we have a polynomial of degree 4, and it has rational coefficients, and it has the given zero. So this is actually kind of like 3 examples in one. So we have 3 zeros given here, and of course if we have degree 4, we know there has to be one more, right? One more. And so we weren't given it, but we have the information to figure it out, right? Because we know that our irrational zeros have to come in pairs, right? Otherwise, we would have irrational coefficients when we multiply everything out. So that other root, the missing zero that is not given, has got to be positive square root of 2, the conjugate to the negative root 2 that we've been given. So same story here, right? We have a complex root, so its complex conjugate for I will be negative I. And we also have to have a conjugate for our irrational. Here, we'll just call it irrational conjugate. And so remember the real part doesn't change, but the rational part doesn't change, but the irrational part does. So we have a 3 minus square root of 3. So this is our first root, our second root, our third root, and our fourth root. And that's all that we have. And so here's just one last one, right? We've got our first complex root, and so we know we have the conjugate. The only thing that changes is the sign on the imaginary part. And then we have our irrational root, and the only thing that's going to change there is the sign on the irrational part. Okay, so now we have all 4 roots for our 4th degree polynomial with 3 of the roots or 2 of the roots given. And a lot of students will say, well, I don't know what the other root is because you didn't tell me what they are, so I can't write it in factored form. But when I do that, one or more of the roots are going to be complex or irrational, and therefore you know it's got a pair. It's got a sister root with it. Okay. So let's see what we got. One more, I think. This one we have a polynomial of degree 5 with rational coefficients. So we know degree 5, we have to have 5 zeros. Some of them could be repeated, but in this case, they're not because we have an imaginary root. So its conjugate will be negative 3 plus 3i. And then we have an irrational root, and so we need its conjugate, which is going to be 2 minus square root of 13. So we have 2 plus root 13. We're going to have its conjugate 2 minus root 13. And there we have 1, 2, 3, 4, 5 roots. And we're done. Okay. So how about one more? Yeah, we can fit one more in. This one doesn't tell you the degree. It just says the lowest degree polynomial with rational coefficients that has the given numbers as sum of its zeros. Now again, if we know if we've got a negative root 2, we also have to have a positive root 2 as a root. And if we have a 4i as a root, we also have to have a negative 4i as a root. Now, could it have more zeros? Sure, but the minimum number, the lowest number of roots that it has to have is these 4. So our lowest degree that meets the criteria is 4, and we have all 4 of them accounted for. So if your problem says just write in factored form, there's my x minus root 2, my x minus negative root 2, my x minus 4i, and my x minus negative 4i. So there we have it written as all straight linear terms, but usually we're going to want to have no irrational numbers, no imaginary numbers, so we're usually going to multiply out, and we would get x squared. Of course, the inside and the outside terms are going to cancel, and I'm going to get x squared minus 2 for this one. And for this one, we're going to get x squared. Again, the inside and the outside terms are going to cancel, and I'm going to get minus 16i squared. I squared is -1, so minus a -1. There we go. And I'm just going to put a little multiply sign in there. So this is what we would generally consider to be irreducible quadratic terms, because we don't generally want to introduce, we don't want to have it in factored form with irrational or definitely not complex roots, okay? But sometimes on a test I'll say, hey, write it as linear factors that might include irrational or complex numbers. So you've got to read the instructions. Okay, so we're going to end this one and we'll get 1 or 2 more and then we'll be done.